Welcome to the 37th video of Quantum Mechanics Done Right, the shortest path from novice to researcher. In this video, I'm going to tell you about the endorsements for the book, and I'm so proud of the cover, I'm going to show it to you again. The first endorser is Sang Hei Chu. I have never met him, but we have communicated over the internet. He's a music director and lifelong learner. And he says, I'm a complete layman when it comes to quantum mechanics, but I've always been fascinated by the subject. While there's no shortage of resources online, most of them are overwhelmingly complex and intimidating until I came across Professor Freerich's edX MOOC, Quantum Mechanics for Everyone. I completed the course with nearly a perfect grade. This course marked the first time I truly learned and understood quantum mechanics. Professor Freerich went to great lengths to make the subject accessible to everyone, regardless of their background. The clarity and depth with which he explains the material are unmatched. That said, I was a bit sad when the 6-week course came to an end. It felt like the journey had just begun, and I found myself unsure of the next step. I couldn't find anything quite like it to build on the knowledge I gained, until now. I'm incredibly grateful for the release of this book, which allows me to revisit what I've learned and dive even deeper into the subject. I want to take this opportunity to extend my sincerest thanks to Professor Freerichs for his dedication to making such a challenging topic accessible to everyone. Next, we have Paresh Kankari. He's a chemical engineer and lifelong learner. I met him through one of my MOOCs, and we're engaging in a research project on calculating wave functions of relativistic hydrogen using just algebraic methods. If you're venturing into the world of quantum mechanics with trepidation, Professor Freerich's book is your perfect guide. As an expert in the field, Professor Freerichs has crafted a comprehensive text that aligns closely with his highly acclaimed quantum mechanics course on edX.org. By investing about a year in this journey, you will be well on your way to becoming a quantum mechanic, in Professor Freerichs' own words. And don't be surprised if you find yourself immersed in quantum mechanics research by the end of it all. Still unsure? Grab the book, enroll in the course, and watch your doubts transform into true knowledge. Take it from a skeptic turned convert. Next up, I have Alan Levin. I believe this is a picture of Alan Levin's grandfather. Alan is both a teacher and lifelong learner. He has worked primarily in the field of chemistry, and he says, in Quantum Mechanics Done Right, Professor Freerichs presents a fresh and unique approach built on years of experience teaching MOOCs and university courses for physics majors. Freerichs addresses the reader as a quantum mechanic throughout the book. This captures both the pragmatic and at times lighthearted spirit that he brings to his challenging endeavor. Make quantum mechanics more accessible without watering it down. Quite to the contrary, compared to other textbooks, he covers more applications and at the same time rigorously explores the algebraic structure of the quantum world to great depth. While Freerichs pays homage to key historical discoveries and persona, he provides distinctly contemporary applications, examples, and exercises. I taught quantum chemistry for years from more traditional texts, yet this material gave me deeper understanding and provided insight into current research. I feel like a quantum mechanic. Now the next endorser is Alex Jacoby. I first met Alex when he was a high school student in the Washington, D.C. area, and I've kept in touch with him and actually have worked with him while he was an undergraduate at Brown University, and now he's a graduate student at Princeton. And Alex says, an introduction to quantum mechanics from the perspective of operator algebras rather than wave functions and differential equations. This perspective is refreshing. It is simultaneously more versatile and elementary than wave mechanics. The book's elementary presentation should not, however, be mistaken for an unsophisticated one. In addition to the basics of operator mechanics, it covers an ambitious and colorful selection of advanced topics. Next, we have Bruce Liu. Bruce Liu is someone who I met through the internet. At the time, he was a master's student in civil engineering, and he wanted to do a PhD in physics. Anyone who has tried to go this route knows that it's very difficult because most physics departments won't take you seriously, even if you've taken the proper courses that are needed for physics, which Bruce had done through lots of online study. I worked with him on a research project. We worked on the Cartesian factorization method for hydrogen, and he got admitted into 2 universities for a PhD program and recently finished from University of Tokyo and is now a postdoctoral fellow. This book develops a modern approach to quantum mechanics that can hardly be found anywhere else. Existing textbooks have an unbalanced focus on how to do calculations. It is difficult to develop a feeling or a sense of what is going on intuitively. In this book, the first 4 chapters introduce a series of mind-boggling experiments to help develop an intuition of the utter strangeness of the quantum world. This intuition is strengthened further in later chapters when a technical calculation is followed by a relevant real-world experiment. Using a unique operator-focused methodology, more materials are covered, including applications in quantum many-body systems, chemistry, and quantum information. This modern treatment of quantum mechanics will be a treasure to a new generation of physicists. Anyone who wants to learn quantum mechanics can benefit from this book. Next, we have Mark Hannum. Mark Hannum is a high school instructor at Thomas Jefferson High School for Science and Technology. Thomas Jefferson is often rated as the #1 high school in the United States, and Mark has taught their quantum mechanics class to high school students for many years. And Mark says, quantum mechanics, one of the crowning achievements of physics, launched the scientific revolution. The teaching of quantum mechanics, however, has been stuck in dogma and tradition. Quantum mechanics done right successfully breaks from tradition, providing an entry point for beginning students with minimal prerequisites, yet maximizing rigor and application. By eschewing the traditional calculus approach and focusing on the algebra of operators, this book provides a representation-independent narrative that is a more comfortable start for many beginning students. As a high school teacher, I know the concept-first, math-second approach Jim takes is the best pedagogical approach to build long-term conceptual understanding. Using clear, friendly writing that invites thought and analysis, the student is invited to explore beyond the typical historical slog to topics such as quantum information science, quantum sensing, and other modern applications of quantum research. Frankly, the topics my students are most interested in. Julian Chen was a researcher at IBM for many, many years, working primarily in scanning tunneling microscopy. After he retired, he became a professor at Columbia University in their Applied Math and Applied Physics department. And Julian says, by any standard, this book is a 21st century masterpiece of quantum mechanics. It is unique that all mathematics are algebraic with no calculus, including derivations of several important wave functions. Such a pedagogy enables a deeper understanding of quantum mechanics independent of representations. The prerequisite is high school level mathematics. Nevertheless, many advanced topics, especially regarding quantum information science, not covered in ordinary textbooks, are presented in detail using algebra. The book touches quantum foundations in depth, especially the key issue measurement. By analyzing many experiments, the author concluded that no real measuring device resembles von Neumann's measurement postulate. Furthermore, the E2E experiment is presented. The hydrogen 1s wave function was observed and measured with a high precision. Those contents, nicely matching John Bell's 1990 article Against Measurement, could lead to breakthroughs in quantum foundations. I recommend this book to everyone interested in quantum mechanics. Next, we have Tom Devereaux. Tom Devereaux is a colleague of mine. I've worked with Tom Devereaux on many different projects since we were postdocs together at UC Davis in the early 1990s. Tom says, one of the biggest challenges in teaching quantum mechanics is addressing the diverse backgrounds and preparation levels of students. Many textbooks either overshoot or undershoot their audience, but Jim Freerick strikes a rare balance. His Modern Quantum Mechanics textbook builds the subject from the ground up, beginning with elementary spin concepts and gradually developing the core postulates. Packed with engaging anecdotes, fully worked examples, and numerous exercises, this book is accessible to students with only a high school math background while offering enough depth and rigor to engage those with stronger mathematical foundations. By using an operator-only approach, completely free of calculus, Freerick presents a broad spectrum of examples, ranging from fundamental to advanced, that students will find both compelling and valuable for their research. I highly recommend this book. Next, we have Kiko Galvez. Kiko Galvez is a professor at Colgate University, and Kiko has been working for many years in trying to bring single quantum experiments to students in the classroom, and has even taught undergraduate classes where the students perform many different single quantum experiments. The book is a fresh approach to teaching quantum mechanics, addressing a number of interesting and compelling problems at a level that is accessible to undergraduates. I particularly like that the book is unafraid to address the subtleties of the most fundamental concepts of quantum mechanics that inspire controversy and misconceptions. It covers the deep fundamental concepts that are the essence of modern thinking about quantum mechanics. Next, we have H.R. Krishnamurthy. Krish has been a collaborator of mine again for many, many years. He's at the Indian Institute of Science, which is the top university for science in India. And Krish says, the book Quantum Mechanics Done Right by Jim Freerichs is a unique, refreshingly new addition to the rather large family of textbooks on quantum mechanics. Its uniqueness is in that it makes quantum mechanics accessible to motivated undergraduate and graduate students, and even citizen scientists who lack the years of math and physics prerequisites beyond high school math and physics traditionally demanded of people interested in learning quantum mechanics. In particular, it completely avoids the use of calculus. The other math skills essential for learning quantum mechanics are presented within the book, making it self-contained. The breadth of topics discussed, which include many that are not normally covered in traditional sequences of even graduate-level quantum mechanics courses, is astounding. The many original problems, video links, and the open access electronic version make it a book of extraordinary value. Heartily recommended even to people who have already been exposed to quantum mechanics. Next, we have Elliot Lieb. Elliot Lieb was one of my instructors when I was at Princeton University. I took a differential geometry course from him, and I have collaborated with him on a number of different projects over the years, primarily during my early career. Elliot is rather succinct. He says Freerichs masterfully and patiently leads the reader into the landscape of the quantum world. Next, we have Maciek Maszka. He's at the Wrocław University of Science and Technology. He has been a collaborator with me for many years as well. There are many textbooks on quantum mechanics, and at the time Jim Freerichs was working on this one, I saw no need for another. But this one turned out to be different. That does not mean that it is better or worse. However, there is an audience, people who are unfamiliar with or unwilling to use some highly advanced mathematical methods, for whom it will definitely be one of the best. The approach taken, while not always the most straightforward, makes the material in it accessible with a basic knowledge of algebra, without the need to take advanced courses in mathematical analysis. Moreover, while maintaining this rigor, Freerichs is able to introduce the reader to the world of quantum mechanics in a very natural way, starting from the most elementary foundations and allowing one to become familiar with its latest aspects that may drive the second quantum revolution. Next, we have Chris Monroe. I worked with Chris Monroe on some simulations of quantum mechanics in ion traps that became some of the foundation work that later led to the development of the quantum computers that are at IonQ. I'm not taking any credit for developing any of the hardware, but I collaborated with him on some of the theory. He is now a professor at Duke University, and he was one of the founders of IonQ, although he is no longer in a day-to-day role with the company. Chris writes, Quantum Mechanics Done Right is a bold title for a bold book that rigorously develops the theory of quantum mechanics from a new perspective. No calculus or differential equations, no outright Copenhagen interpretation, and its philosophical conundrums associated with wave function collapse. Freerichs doesn't try to philosophically paint his approach as avoiding the sticky measurement problem in quantum physics, as many others have breathlessly attempted. Instead, he introduces the topic to readers who have never studied physics or quantum mechanics, but are not afraid of logic and rudimentary mathematics. This approach is timely, as quantum mechanics is evolving from an esoteric topic relegated to university physics departments to an essential basis for new technologies such as quantum computers and quantum communication systems. The book is exhaustive but written conversationally with hundreds of figures, portraits, website links, humor, and other vehicles to draw in any reader, including those who are quantum physics experts. Freerichs surprisingly integrates current topics such as gravity waves, the Hubbard model of electronic transport in solids, and even trapped atom quantum simulations. I expect this book will be a valuable reference for anybody interested in diving into the foundations of quantum information science and technology, and it may help broaden the rank of those who call themselves quantum mechanics. Next, we have Branislav Nikolic. Branislav was a postdoctoral fellow with me. He's been a professor at University of Delaware for probably about 20 years now. Branislav says, this is a one-of-a-kind textbook charting a path for modernized education of quantum physics and engineers for the 21st century. Traditionally, instructors have to select one textbook for an introductory course, another one for the next graduate level course, and yet another one for an advanced course on many-body quantum systems reaching applications in condensed matter, quantum optics, or quantum chemistry. With Freerichs' textbook, it is possible to start from basic experiments on polarized light and electron spin and progress all the way to treatise of magnetism, strongly correlated electrons, quantized light, ion qubits, coupled cluster theory and chemistry, Lindbladian dynamics of open quantum systems, and more. On this path, Freerichs also teaches you how to solve many problems encountered in conventional textbooks, but in a non-traditional way. Remember a quote from the blackboard of Feynman lectures at Caltech: know how to solve every problem that has been solved, such as by using operator algebra and representation-independent calculations that founding fathers, Dirac, Pauli, and Schrödinger, initiated, and which Frerichs has carefully studied and extended through prior pedagogical articles integrated into this textbook. One of the weakest points of many conventional textbooks is coverage of time evolution, understandably so, as it is still the subject of intense research. In a chapter on that topic, Frerichs will teach you the Trotter product formula and other tricks with exponents of operators that are used in modern research on tensor networks and simulations using quantum computers. Thus, by reading a single textbook and working through its numerous clarifying examples, students will be able to transition from novice to navigating frontier research literature. Next, we have Anna Maria Ray. I've written a couple of papers with Anna Maria. She is at Gilla. She also is a MacArthur Fellow. Quantum Mechanics Done Right by Professor Frerichs is the book for anyone eager to learn quantum mechanics quickly and deeply. These used to be incompatible priorities, but Professor Frerichs has been able to create a book that strikes a perfect balance between fundamental concepts and modern developments, making it an excellent resource for students and teachers alike. What sets it apart is its inclusion of basic core concepts applied to real problems relevant to modern quantum technologies, providing students an exposure to cutting-edge ideas. Some of the chapters offer a handy collection of important formulas, while the biographies add a human touch, making the reading experience even more engaging. I have long searched for a book that bridges core principles with frontier topics, and this one does so brilliantly. I'm excited to use it in my courses and deeply appreciate the author's effort in creating such a valuable resource. Next, we have Terry Robinson. I have never met Terry in person, but we have communicated over the internet many times. Terry has a very interesting way of introducing quantum mechanics through the notion of counting. And I strongly encourage anyone who is intrigued by that concept to get a copy of Terry Robinson's book and go read it. It's a fantastic book. His approach is a little bit different from mine, but we meet after the initial developments and ultimately land on the factorization method of Schrödinger, which is something that he uses in his book as well. This remarkable new book by Jim Frerichs is not only an original approach to the mathematical development of quantum physics, but is also encyclopedic in its attention to detail. It contains a wealth of material on a huge number of quantum topics, including experiments, that demonstrates the author's wide-ranging knowledge of the subject. The absence of traditional calculus proves to be a major advantage since it leads to a level of algebraic clarity that is rare in traditional approaches. It allows the necessary operator maths to be developed entirely from simple associative matrix algebra. The non-associative differential aspects are carried by commutators by which implicit differentiation is accomplished. Even if this book is not followed step by step in university courses, it will provide a tremendous resource for physics teachers and physics students alike. Strongly recommended. Next we have Wolfgang Schleich. He's from the University of Ulm. I met Wolfgang at a conference in Prague that both he and I have attended for about 20 years. The conference runs every 2 or 3 years, but I actually only met him the last time that it ran, and we are kind of simpatico, and I really have enjoyed interacting with him, and I have sent him chapters from the book for comments, and he writes an endorsement here as well. James Frerichs has woken up the sleeping beauty of matrix mechanics. On the centennial of its birth, he argues in his impressive modern exposition of this theory very convincingly for the use of operators rather than wave functions. Indeed, his representation-free approach yields considerable new insights into numerous odd features of quantum phenomena, as illustrated by examples spanning an amazing range from the ubiquitous measurement problem via atom interferometers to Landau-Zener transitions. It is high time that operator techniques receive more attention in physics classes, and this book provides the perfect entrance, a must-read for every physicist. Next we have Stamatis Vokos. He's at Cal Poly in San Luis Obispo. Stamatis was my TA for quantum mechanics when I took it as a graduate student at Berkeley. So I have known Stamatis for about 40 years. Jim Frerichs masterfully presents a novel, operator-based approach to the treatment of quantum mechanics, one that responds to the emerging needs of a 21st century audience. The traditional canon is based on facility with solving ordinary and partial differential equations, making quantum mechanics inaccessible to most STEM students and professionals. The proposed approach brings many of the cutting-edge results of quantum mechanics within the reach of committed readers without the traditional mathematical preparation of advanced calculus courses. In fact, the content of the book delivers what the title promises, taking a dedicated, motivated novice and elevating them to a researcher on the subject with a disciplined application of knowledge and tools that are carefully developed and applied in a variety of standard examples and contemporary contexts, including through engagement with rich, innovative questions at the end of each chapter. And finally, I asked Barton Zwieback. He's a professor at MIT. He has a famous MOOC on quantum mechanics that is offered originally by edX, now by the MIT online organization. I think they just call it MITx. And he has also recently written a quantum textbook. It's a fantastic textbook if you're interested in the more traditional way of doing quantum mechanics. A novel approach by Frerichs, professor of physics at Georgetown, who presents quantum mechanics with little mathematical requirements but plenty of physical insight. The book is an exciting ride that will take you deep into the subject, emphasizing modern developments. Before I end this video, I would just like to provide my sincere thanks to all of those who provided endorsements for the book. Many of you have been long friends of mine, but I really thank you for the time that you took to read the book and provide comments in a short time frame. And I'm really thankful for the time and effort that you put in for doing that. Hey guys, let's do quantum right.